David Smith here with one more flipped classroom math video for your enjoyment. 3 tips. First, you can speed up or slow down the playback if that helps you follow along. Second, you can pause anytime to catch up with your notes or think a little harder. Lastly, you could turn on the captions, which will show you my words on the screen below. Today's topic deals with bivariate data. So previously in our chapter, we've been dealing with univariate data, which is data with one variable. Bivariate data simply has 2 variables. So let's take a look at some points, a little bit about where we're going today, and then we'll get into it. So this is data that's collected from the same individual or situation. So if you've been doing some data research, you might have interviewed people and found out 2 things about them, like perhaps their age and their country of origin, or perhaps their height and their weight, 2 variables that you can then compare. So that's what we do, is we compare the 2 variables to see if there's a correlation. Do the 2 variables change together or change with some kind of relationship that we can analyze? So that's what correlation is about. I want to introduce a caution here. Correlation does not mean causation. So even though 2 variables might correlate, they might change together in a predictable pattern, one might not be causing the other. There could be a third cause underneath those 2 variables. So you have to analyze your situations carefully to figure out whether there is causation involved. Finally, we're going to talk about types of correlation. There can be strong correlation, moderate, weak correlation, or perhaps correlation does not exist at all. All right, let's talk about independent and dependent variables. Now, if you're taking a science class, you're probably bumping into that as well. I hope you are. This is an important concept in dealing with data. So before we go into the definitions of these 2 things, I would like you to pause the video, take a look at notes, get on the internet, Google these terms, see if you can come to your own understanding of what the independent variable is and what the dependent variable is. All right, let's see how you did. So the independent variable is the one that you pick. This is the one that you think might be causing something in the world, or that you're testing with your data to see if there's a correlation or even a causation. So this is the one you pick. When you make a graph, you put the independent variable on the x-axis. Like for example, if we're trying to figure out distance covered during a trip, we would put time on the x-axis. That's the one we control. That's when we take our measurement of distance, depends on the time. And then the distance would be on the y-axis. And that distance depends on time. So you can see how in that example, the independent variable would be time and the dependent variable would be distance. And so let's take a look at that definition. The dependent variable is the one that you think might depend on or be caused by the independent variable. Okay, so, and this one gets graphed on the y-axis. This relates a little bit to function notation and the idea of functions in mathematics, that a function is something that takes an x value, which you choose, independent variable, you put it in the function does its thing to it, and it spits out the dependent variable, which is the y. So the y value depends on the x. So this is an idea that exists in science and in mathematics, and of course now in statistics. So I would like you to think of one more example of a situation where you have an independent variable that depends on the dependent variable. This could be any real life situation. Just pause the video, think about that for a minute. Okay, so obviously I can't tell what you came up with, but I can come up with one more just to drive this point home. Let's say we're trying to measure boiling point of various fluids. So think about that for a minute and think about what the dependent and the independent variable would be. Okay, so what do we control in that experiment? We're taking fluids and we're adding heat. What happens when we add heat? Temperature goes up. So we're controlling temperature by adding heat. So that's the independent variable. The dependent variable would be the temperature at which it boils, or what we'd call the boiling point. And then we can make a graph with temperature along the bottom. That's what we control. And we can plot points for the different boiling points for each fluid. All right, let's analyze a situation with 2 variables. So here's the data that you've got. I'm giving you in a nice big fat table. We've got number of past IB papers that were completed. So you can see students did different amounts of papers, right? Someone did 10, someone did 2, someone did 1, etc. And then connected to that data, how many past papers they did, you've got their exam grade in a percentage. So here we have a column of exam grades. So first off, just do a little bit of what we call data snooping. That's just a look at the data and see what you can see. See if you notice anything. Okay, if you notice what I notice, it seems pretty clear that the more papers were done, the higher the exam scores are. Cool. I mean, and that's kind of logical. It makes sense. Think for a minute whether we have simply just correlation or if we actually might have causation. This is just a reasoning. We're not doing an experiment, but just think about that. Do you think we would have causation here? Okay, myself personally, I think probably, because the more papers, the higher the test score. That makes sense. The more papers you're doing, the more studying you're doing, the more familiar you're getting with the material. So all those things will contribute to getting a better exam score. But we have not proved it, okay? So maybe there's another cause underneath that correlation, okay? So you have to always think about, perhaps if you're doing an experiment, that's where you get into the nitty-gritty of trying to figure out whether or not you have causation when you see a correlation. Okay, so what we need to do to kind of take a look at the type of correlation and how strong it is we need to make a graph of this data. And in this case, we have data points that are going to kind of be a little bit all over the place. So we're going to make what's called a scatter plot. So I'm just going to go ahead and put one up for you and then we'll talk about it. Okay, so I made my scatter plot and I just graphed my points from my table. I made my vertical axis, my horizontal axis. Notice how I use my scale break here. I don't need 10 to 40 because there's no scores less than 40, but you do want to do a scale break. And notice how I put my numbers and tick marks along the scale. Just you got to do that to make sure everything works right. And it looks like we've got a pretty decent correlation there, okay? There's not data that are wildly away. You might be tempted to draw a line through there. And in fact, you could do that. You can actually have a computer analyze your data and draw what's called a least squares fit line that will actually draw a line that best fits that data and even come up with an equation for that. And you could use that equation to do predictions. If you met a student, they said, well, I did 6 papers, you could put that into your equation as an independent variable, and it would predict what their score would be as the dependent variable. All right, so now that we've established that we have a correlation here, we want to talk about the character or the type of that correlation. And there's 3 words that we use to describe the correlation. One is strength, the second one is direction, and the third one relates to its linearity, or is it linear or non-linear? So pause the video, take a look at the notes there, and come up with a description for this correlation. Pick something from each of those groups and see what you get. Okay, this one is a strong, positive, linear. And I realize that question might have been a little bit unfair in that maybe this is the first correlation that you've been asked to judge based on those 3 characteristics. So let's go over that. Strong means those points are pretty close together. We're not spread out. We have points that are pretty close together, so that makes that a strong correlation. No, they're not in a straight line, but you don't need that for a strong correlation. Direction, positive. X or Y increases with X. One way to think about that is it's just simply a slope thing. This has a positive slope, so it's a positive correlation. And that makes sense. The more papers you do, the better score you're going to get. So there's a positive correlation between that. Okay, the last one is whether it's linear or non-linear. And this one's linear because this is going pretty much in a straight line. I mean, it's a little bit wiggly, but we don't have any kind of a curve, like a curve up or a curve down, things like that. So again, strong, positive, linear correlation. All right, let's take a look at another example. So here's my data. This is the storage temperature. It might be the temperature that's set in the refrigerator or maybe in the room where the sour cream is stored. So then we have our independent variable there, temperature, we control that. Days to turn sour, we don't actually control that. We control that by setting the temperature. So as the temperature gets higher, the days to turn sour gets lower and lower. So at 4 degrees Celsius, the sour cream will stay good for 15 days. But as we go on, as we increase our temperature all the way up to 28 degrees Celsius, the sour cream only lasts 1 day. Now this makes sense, and I want you to think for a minute about correlation versus causation. We'll get to that in a sec. So there's my data graph. I graphed these data points. So I want you to pause the video and comment on this data on the 3 attributes that we talked about before. There were strength, direction, and linearity. Okay, here's what I get. I get strong. Looks pretty much in a line, not too bad. I get negative as the days, as the temperature gets higher, days to sour gets lower. And it fits the slope. We have a negative slope, so we have a negative correlation is how we say that. So as we increase temperature, days to souring decreases. Okay, so you have plenty of examples in life where you have negative correlations. Finally, I would say mostly linear, not quite. You can see there's a slight lessening of the trend there. It's starting to asymptote out a little bit. We're not quite linear with that. Let's comment on correlation versus causation. Now you know the situation here, so I want you to think real hard and decide whether we have simply correlation where something else could be causing the change in the dependent variable, or whether the independent variable is causing the change in the dependent variable. Okay, if you're like me, causation makes sense. The warmer the storage temperature, the quicker something is going to go bad. We just know this from life. I mean, we could do an experiment and prove that, but I think it would be pretty safe to say that we have causation in this situation. Okay, let's look at one more example, and I want to give you context for this so that you can evaluate the data and our graph for correlation. So let's pretend like I'm a promoter of exercise for health, and I want to show statistics that show that the more you exercise, that helps with weight loss. So that would be a good thing for me as a business person. Come on in. Action. So what I'm doing is I've created a table here that shows the minutes of exercise per week that a person does in my program, and then their weight. And the idea is that this data is going to support the idea that the more exercise you have, the less weight you will have. So I've got my data here. I made a scatter plot. I want you to pause the video right now and tell me what kind of correlation you see there. Okay, if you noticed, it's probably a strong correlation, maybe moderate. These data aren't quite in a line, but it's pretty good. It's negative correlation because we're sloping down. And again, it's almost linear, but not quite. So I want to ask you, what do you think about causation? Do you think that we have, I mean, it's known that if you work out more, you can lose weight, but how about our data? Given what you know, do you think you could say causation? Okay, if you said no, you're right. There's a whole lot we don't know here. We don't know if this is males or females or if there's a mix. So generally males weigh more, so all the higher weight data points could be men and the lower weight data points could be women. There's a whole lot of explanations. I'm sure if you thought about it, you could come up with other things that cause this correlation that aren't minutes of exercise. All right. One last little exercise to test your understanding. I've put up 6 scatter plots here, and I want you to pause the video, jot them down into your notes, and I want you to pause the video and then tell me what kind of correlation you think we have in each of these plots. And remember, you want to characterize it based on strength, based on direction, and based on linearity. So go ahead and pause the video and do some thinking on that. All right, this first one, I would say moderate correlation. It's not tight. The data is spread out a little bit. It is positive, and it does look linear. So I would say moderate, positive, linear correlation. Okay, so now take a look at that graph. and decide. All right, that one, I'm going to call it weak. I think we do have correlation because generally the dots, the points in our scatter plot are decreasing, but they're pretty far spread out. So I would call that a weak negative correlation. And then I put a question mark by linear. With a weak correlation, it's kind of hard to say whether we really have a line going on. Now, if you're savvy with your calculator, you could put this data in there and ask for a least squares fit line, and it would draw a line there. And so maybe that would give you a sense of whether it's linear or not. Okay, so now do the next one. All right, so this one, I get strong. The data points are pretty clustered together. I get positive. As x is increasing, so is y. And then I'm going to have to say non-linear. It starts curving upward a little bit gradually. So I put in there exponential. It could also be quadratic. Our book doesn't go into that level of detail, but being a math guy, I like to do that. Okay, now try that one. Pause the video and see what you get for that one. Okay, for this one, I get no correlation. These dots are pretty much everywhere. Up and down, left to right, there's no clear trend. So in this case, I would say there's no effect of the independent variable upon the dependent, or at least based on our data, no correlation. Okay, try that one. Okay, I think you're probably getting the hang of this. This one is a strong correlation. Our dots, our points are pretty close to being in a line. We've got negative. As x increases, y decreases, so that's a negative correlation. And I would say that that's definitely linear. Okay, last one. And that's kind of weird. So pause the video and tell me what you think. All right, so I just put no correlation there. Now, it does look like we have a pretty decent correlation. It's just that it's not one thing increasing causing another to increase or decrease. It looks kind of like a parabola. So this is like, it's looking to me like a quadratic relationship between the variables, but we don't really talk about that in terms of correlation. Now, one of the things you can do is you can divide it in half, and you could say on this side, we have a strong positive nonlinear correlation, and on this side, we have a strong negative nonlinear correlation. And so you could do that, and maybe there's a situation out in the world where your independent variable causes this kind of a change in your dependent variable. All right, now that you've watched the video, take a minute and jot down any remaining questions so you can bring them to our next class. Also remember, you can watch the video again. Maybe that will deepen your understanding. If you like the video, please click like and subscribe.